Welcome to this explainer. Let's be real for a second. If you've ever felt like your devices are basically running your life, you are definitely not alone. Today, we're diving deep into the literal neurobiology of our screen compulsion, and we owe a lot of this perspective to experts like Dr. Ronnie Rodas, who's been doing some incredible work trying to figure out and predict the future of how social media is going to impact us as humans. So let's look straight at the science to decode exactly what's happening inside our heads when we're plugged into the digital world.
So, picture this. Why is it that we open our phones to do just one simple thing, like send a text, and suddenly we're completely pulled underwater? 20 minutes literally vanish, and you can't even remember why you picked the thing up in the first place. Look, this visceral, incredibly universal experience of just mindless scrolling, it is not a sign of laziness. Seriously, as neuroscientists are quick to point out, this disappearance of time is actually a highly engineered design outcome.
Which brings us to this absolutely staggering number, 96. That is the number of times the average person checks their phone every single day, 96 times. Now, we almost always blame ourselves for this, right? We think, oh, I just have terrible willpower. But it's not a failure of willpower at all. That number is the product of a brilliantly engineered feedback loop, one that is specifically designed to hijack the exact same reward circuitry in your brain that drives gambling and substance use.
Section 1. The slot machine brain.
Okay, so the foundation of this whole brain hijack is something called variable ratio reinforcement. Basically, this means rewards are delivered to you at completely unpredictable intervals. Think about it. When you're swiping through a social media feed, you have absolutely no idea if you're going to see a hilarious video, a message from an old friend, or just nothing. In neuroscience, they call this a reward prediction error. See, your dopamine neurons don't just light up when you get a reward. They actually fire the absolute hardest based on unpredictability. It's the gap between what you expected and what you got. And wouldn't you know it, it's the exact same reinforcement schedule used to make casino slot machines so wildly compulsive.
To put this into perspective, let's look at psychologist B.F. Skinner's famous 1971 experiment. He put a pigeon in a box. When the pigeon got food every single time it pressed a button, it just ate when it was hungry. Simple. But when the food became unpredictable, that pigeon pecked the button compulsively. Now scale that up to billions of humans on smartphones and, well, that's us. We are scrolling for those unpredictable likes, comments, and novel bits of content. And the really crucial takeaway here is that repeated exposure to all this overstimulation eventually creates a chronic dopamine deficit state in the brain. It literally leaves us feeling anxious and way less able to just enjoy normal everyday pleasures when we finally put the phone down.
Section 2. The collapse of attention.
Now, based on over 2 decades of research by attention scientist Dr. Gloria Mark, take a look at the trajectory of our screen attention span. Back in 2004, the average time someone spent focusing on a single screen before switching was 2.5 minutes. By 2012, that plummeted to 75 seconds. And by 2020, a mere 47 seconds. We are witnessing the literal, measurable shrinking of human attention spans on screens. Our digital environments are built to prioritize rapid, constant context switching, and over time, that is quite literally weakening the neural networks we use for sustained attention.
Because here's the thing, true focus isn't just a mood or a fleeting feeling. It actually has a physical, measurable EEG signature right there in your prefrontal cortex. When we are deeply locked into a task, our brains show elevated low beta activity, reduced theta wandering, and strong alpha coherence. But chronic high-frequency digital engagement and always paying partial attention to things, that actually alters the physical structures governing our impulse control. Without dedicated practice, those focused brainwave patterns weaken. It's a dark side of neuroplasticity. We are literally training our own brains to be distractible.
Section 3. Memory in the digital age. All right, so this brings us to something known as the Google effect. This is the phenomenon where we naturally start storing information externally on our devices rather than internally in our own heads. Because we know we have instant access to this endless global bank of information right in our pockets, our brains basically decide, hey, I don't need to do the heavy lifting of remembering this. And over time, that leads to faster forgetting and far weaker active recall. It's a steady march toward what some researchers are calling digital amnesia.
And it actually gets more specific than that. Different digital tools target completely different memory systems. So when we rely on GPS navigation everywhere we go, we offload our spatial memory, which actually weakens processing in our hippocampus. When students lean heavily on generative AI to write essays or solve complex problems, they completely bypass deep encoding and active rehearsal. And relying on basic search engines, that externalizes our declarative memory. Researchers call this the efficiency atrophy paradox. Basically, yeah, these tools make us incredibly efficient in the short term, but we pay for it long term with the atrophy of the cognitive muscles we need to maintain a strong, unassisted memory.
Section 4. The loneliness paradox.
Let's talk about the number 150. This is famous as Dunbar's number. Anthropologist Robin Dunbar proposed that the human neocortex actually has a biological size limit, meaning we can only comfortably maintain about 150 stable social relationships. That is our natural limit for knowing who everyone is and how they all relate to each other. Our brains literally evolved to manage deep, localized communities, definitely not the hyper-connected, globalized networks of billions of profiles that we navigate today.
And because of that, our modern digital lives are completely dominated by this massive, overwhelming network of weak ties. Followers, passive acquaintances, parasocial connections. And that giant web completely overwhelms the tiny, essential core network of our strong ties, our true close confidants. Social media platforms encourage incredibly high network turnover, and they replace actual physical, nonverbal interaction with cheap digital validation. This actively prevents us from forming those stable, deeply trusting relationships. So we're left with this crazy paradox. Despite having unprecedented digital connection, self-reported social isolation and loneliness are absolutely skyrocketing. Why? Because our brains simply do not process digital metrics as true physical safety and belonging.
Section 5. Youth and the anxious generation.
This massive systemic shift naturally makes us look at the most vulnerable people navigating it, children and adolescents. Now, on one side of the intense debate over the youth mental health crisis, you have social psychologist Jonathan Haidt. He argues that a huge driver of the current epidemic of teen anxiety is the very rapid shift from a play-based childhood to a phone-based childhood. Haidt points out that right around the early 2010s, exactly when smartphones became ubiquitous, adolescent mental health just plummeted. He links this to 4 foundational harms of digital environments: social deprivation, sleep disruption, attention fragmentation, and straight-up addiction. So in his view, swapping out unsupervised, somewhat risky outdoor play for constant 24/7 online social comparison is fundamentally rewiring our kids for anxiety.
However, the scientific community is definitely not totally united on this conclusion. The main counterargument, which is championed by developmental psychologists like Candace Odgers, gives a strong caution. Correlation does not equal causation. Odgers argues that the data just doesn't consistently show a huge negative effect that is uniquely caused by screens. Instead, she points out we might be looking at reverse causation, meaning perhaps young people who are already struggling with underlying mental health issues are simply turning to screens and social media more often to find comfort or an escape. From this perspective, if we focus all our panic solely on the technology, it might actually distract us from addressing the real underlying societal issues causing this crisis.
Section 6. Reclaiming your neural architecture.
But here's the thing. Whether the tech is the absolute root cause or just an amplifying symptom, the neurobiological impacts of heavy screen use are very, very real. But there is incredibly optimistic news here, and that is that the human brain is highly, highly plastic. The exact same adaptability that allowed an algorithm to fragment your attention is the exact same adaptability that lets you take it back. Clinical neuroscience gives us 3 big steps here. Number 1, break the neurochemical loop of variable reinforcement. That means turning off unpredictable notifications and actively, intentionally designing your digital environment. Number 2, restore physical, play-based interactions to rebuild those core strong ties and signal actual social safety to your nervous system. And number 3, utilize focused attention training. Remember those EEG brainwaves we talked about earlier? Neural circuits that weaken with disuse can absolutely be built back up and strengthened through deliberate, sustained practice.
Your brain is quite literally the most sophisticated information processing system in the known universe, and it is constantly rewiring itself based on whatever you expose it to. Every single scroll, every notification, and every single moment of deep focus leaves a physical mark. So, the ultimate question I want to leave you with is this: are you actively shaping your own brain, or are you passively letting an algorithm optimized for engagement metrics do it for you? Thank you so much for joining me on this explainer. Keep learning, stay focused, and go take control of your neural architecture.